Everyone. Today we are going to learn a topic from 8th standard, that is combustion. So let's start. First of all, moving to it, I want to ask all of you a very small question. Okay. My question is, we are using different kind of fuels, right? We are using different kind of fuels for various purpose. We are using fuels at home, right? We are using fuels at home. Then we are using fuels for commercial purpose also. Yes, I hope that you know that what is fuel, right? I want all of you to tell me that what is fuel. So my question is, we are using fuels for different purpose, such as we are using fuels at home and we are using fuels at commercial purpose. Now my question is, what kind of fuel you are using at home? If you are using a fuel, what kind of fuel you are using at home? The best answer would be your LPG. Now, what is LPG? Few of you will say that gas cylinder, gas cylinder. Yes, I agree. That is a gas cylinder. But what is the full form of LPG? The full form of LPG is liquefied petroleum gas. Okay. It is liquefied petroleum gas. Now, if I ask that, you now from here you should have a small idea that okay, she is referring to some kind of gas which is used as a fuel for burning, for moving things, right? Why we are using LPG? We are using LPG to cook food, right? Now if I am asking that we are using fuels at commercial purpose also, what are those few things? Are CNG. You might have heard petrol. Everybody knows petrol, right? So CNG, petrol and diesel. Now, can anybody tell me what is the full form of CNG? Yes. Okay. So its full form is compressed natural gas. Okay. It is it spreads less pollution as compared to others like petrol and diesel. So till now, what did we understand? We are using fuels. Okay. Fuels are used either at home or for commercial purpose, right? We are using fuels for home and commercial purpose. Now, what these fuels are helping you to? These fuels are helping us to cook food, to move vehicles, right? So fuels are important, right? Fuels are important. Now, one more question I have. Okay, one more question I have. What is the difference between, okay, what is the difference between burning of coal and candle? My question is, what is the difference between burning of coal and candle? Right now, yeah, so you might have seen coal. How many of you have seen coal? You have to raise your hand, right? So coal, if you see, if you are burning coal, it will be some blocks like this, right? It will turn red, but there will be no flame. Okay. Suppose this is your coal. If you are burning coal, you will see that it is black in color, right? After burning it, it will turn into red color, right? So it is not going to give you any flame. But if you have a candle, a beautiful candle, okay, if you have a beautiful candle, even though if you have a normal candle also, it will show you the flame, right? So what is the difference between the burning of coal and candle? Coal, no flame. Okay, coal will not show you any flame, but candle will show you flame. You know flame, right? This is flame. What is flame? Basically, if you are able to see this is called flame, right? So now the difference between coal and candle, you are thorough, right? Now, how the coal is also burning but not giving the flame, and how the candle is burning and giving the flame, what is the reason behind it? So we are going to learn about the chemical reactions. Okay, chemical reaction behind it. Now what is chemical reaction? Can anybody tell me behind it? Okay, what is chemical reaction? If suppose if I am asking what is the difference between chemical and physical reaction, what is chemical reaction? Basically, if suppose you are burning candle, right? burning candle, or let's take matchstick. If you are burning a matchstick, the stick will get over after some time, right? You cannot bring it back into the matchstick. Yeah, few of you will be very, very, very smart and they'll tell that we will take another matchstick and it is how we will reverse it. But my question is, if you are burning a matchstick, the stick which you used will be burned completely, right? So you cannot make that matchstick again out of it, right? That is called as chemical reactions, which means it is irreversible, means you cannot reverse it back. Okay, so chemical reactions are those reactions which cannot be reversed. Okay, chemical reactions can't be reversed back. Okay, can't be reversed back. Done? Understood? So now we are going to learn about what is the process behind the chemical reactions of combustion. Right? Let's move to it. Now, let's go back to your past, not very, very far, but just 1 year. Okay, just let's go to just 1 year back. You have seen something like this. Now people will be like, what is this? We did not see any time. But this is nothing else, magnesium ribbon. Okay, this is your magnesium ribbon. What is it? Magnesium ribbon. Now, why it is here? Because you might have heard about magnesium ribbon in your 7th standard, where we were taking the magnesium ribbon and burning it, so that magnesium was turning into magnesium oxide. That is past memory. Okay. What actually I want to tell you over here is, this is your magnesium ribbon, right? After burning, it is giving you some kind of flame. It is showing you some kind of flame, right? Now, we are talking, remember, always you have to focus on the topic. So we are talking about the chemical reaction behind the burning of things, right? So magnesium ribbon is burning with what it is giving you? Light. It is giving you light, right? Now, let's burn coal, which we did already. It is burning, but it is not giving you light. It is giving you what? Heat. It is giving you heat. In that case, it was giving you heat. Magnesium ribbon is giving you light. Fine. So there are many examples where you will be burning things. Either one of them will give you heat, few of them will give you light. So how do we define combustion? Okay. How do we define combustion? So the definition of combustion is, or we can conclude this by a chemical process. Okay, I told you that what is chemical reaction or chemical process, both are same. A chemical process in which a substance is burned. Substance is burnt. Here is a twist. Is burnt in presence of. In presence of. In presence of what? See, this is magnesium ribbon. We are burning it. Where we are burning? In open air. Okay. Where we are burning coal? Open air. Where we were burning the candle? Open air. In open air, you have a mixture of gases. But the only one gas which is very, very, very important for combustion is our oxygen. Okay, is our oxygen. Means human also need oxygen, and for combustion also oxygen is very, very important, right? So a chemical process in which a substance is burned in presence of oxygen to give heat and light as a product. Heat and light as a product. Okay. Now, repeat after me. What is the definition of combination? A chemical process in which a substance is burnt in presence of oxygen to give heat and light as a product. Now you will be like, uh, just reverse it. We want to, again, we want to revise it. We are not able to understand. So I'll tell you easy. Okay. Suppose you have taken magnesium. Already you have a magnesium ribbon over there. Now in air, we are using oxygen, O2. Done. What you will get? MgO. Okay, you will get MgO. The whatever ashes will be collected in this tray, this will burn, right? If you suppose if you are burning a paper, there will be ashes, right? Same thing will happen with this Magnesium ribbon also, if you are burning it, some ashes will be there. This ashes is nothing but the product, and how it is produced with the help of heat or light. Okay, heat or light, you are getting MgO, right? So balancing is a thing. So I have balanced it. This you will learn in 10th standard, right? So till here, am I clear that what is combustion, how we are using in day-to-day life, and what is the definition of combustion? If you are not thorough with the definition of combustion, I have written on the screen. Please go through it once, twice. You will be able to give the answers, right? You will be able to give the answers. Now, here we are using combustion, here we are using magnesium ribbon, right? That is a substance basically. Magnesium ribbon is a substance, right? Yeah, magnesium ribbon is a substance, correct? Substance, okay. If I take a piece of paper, that is also a substance. Yes, it is. If I take candle, that is also a substance. Like basically, whatever we are taking, let's consider that is a substance. If I'm taking this pen also, this is also a substance. But let's take two prominent examples, like magnesium ribbon we have taken as one, and let's take another example like iron nail. Iron nail, okay, not this nail, not iron nail, okay, that is iron nail, which we use in our household for keeping pictures, for various purpose, for hanging things, okay. So that iron nail. Now, if I use matchstick to burn the magnesium ribbon, okay, if I use matchstick to burn the magnesium ribbon, I will be able to burn it, correct? Yes. If I am using iron nail and burning it, can I burn it? No. What is the reason? What is the reason behind it? Because the magnesium ribbon is your combustible substance. What is combustible now? And this is your non-combustible. What it is? Non-combustible. What is it now? What do you understand by combustible and non-combustible? Yeah. So in easy language, if I say combustible substance, okay, if I tell you what is combustible substance, the substances which take part in our combustion is called combustible substance, okay, takes part in combustion. The substance which take part in combustion is called as combustible substance, and non-combustible substance can be defined as which does not take part in combustion. Understood? Take part in combustion, right? Okay. So what did we learn? We learned about combustion. What is combustion? Then we learned about what is combustible substance. Then we learned about what is non-combustible substance. Now I have a very nice activity for all of you. Now what you have to do, you have to collect randomly 4 to 5 materials around you. Okay. Suppose you can have a hair clip, you can have a paper, you can have a pencil, you can have a stone, and you can have anything. Like you can collect out of 5 to 6 you can collect. Now out of those you have to mark, you have to first of all make a box, okay, make a box like this. This is a fun activity, okay, make a box like this. Here you have to write the name, what substance you have taken, that substance name you have to write. Here you have to write combustible, okay, here you have to write combustible. The last box will be non-combustible. So what you have to do, you have to check it out. Be careful while doing this activity, okay. When you are burning it, if you are able to burn it without any restriction, you are able to burn it very easily, then it will go under mark here combustible. If suppose you have taken A, okay, let's take paper. If you have taken paper and if you are able to burn it, you have to mark over here. Now if you have an iron nail, okay, you are not able to burn it, so you will mark like this. So you have to do this activity and submit it to me. Okay, I just hope that all of my students are so good that they will do it, right? Fine. So Now it's your turn to tell me what is combustion, combustile, and non-combustile substances, right? Fine. Okay, let's move to the next one. Now here you have a diagram. Wow, nice candles, right? Now, if you see A, B, C, three candles we have taken. This is chimney. This is called as chimney, or you can tell as a glass jar also. Glass jar. Glass jar will be less confusing, right? Glass jar. Okay. And this is cardboard sheet, basically. Easy. Cardboard sheet. Correct. Now, what is going to happen over here? You have to take a candle. Like how they have placed, you have to place like same thing. Now, what is the difference in all the three diagrams? If you see in the first diagram, okay, it is open from upside as well as downside. Okay, be careful with the diagram. Look at the diagram carefully. Okay, it is very, very, very important. Now, if you see in the A, top and bottom both are open. If you see in the B, what happens? Top is open. Okay, top is open, but downside it is closed, right? In the third diagram, what is happening? Downside is also closed, top side is also closed. So what will happen? What will be the effect on combustion? Combustion is nothing but burning of a substance, right? Simple. If I am asking, but yeah, there is a process behind it. I will agree to it that there is a process behind it. But in general, combustion is burning of a substance, right? Now, if you see in the first case, let's suppose you have a first case. What is happening over here? In the first case, nicely candle is burning. Okay. Candle burns out well. Fine. In the second one, candle flickers. Flickers means what? Have you seen birthday candles? If you someone will blow, it will be like a, it will make some popping sound and then it will blow off, right? That is only flickering. Candle flickers and blows out. Blows out, okay? C is candle is not burning basically, right? It is not burning. In the second case, after some time, it will flicker and blow out. It means it will be not burning. Now, what is happening? First case, from top and bottom, you are getting air. Air, oxygen, oxygen, combustion, right? What did I say? I said air, oxygen, oxygen, combustion. Means for combustion, our oxygen is very, very, very important. Okay, for oxygen, for our combustion, oxygen is very important. Now, if you go here, yeah, from top side yeah, from top side you are getting that. But what is happening to your bottom? It is closed, right? It is closed. Now, as it is closed, what will happen? It won't get the proper oxygen. If it is not getting the proper oxygen, what will happen? It will it will give some smoke, with smoke. Okay, remember, this is with smoke. It will give some smoke and it will be burnt off. Now, if you go for third one, in that, if you see, yeah, in that, if you see, what is going to happen over here? In that, what is going to happen over here is, in that, what is going to happen over here? Just a second. Yeah. In that, what is going to happen in the third one? We were talking about the third one. What is going to happen over there? In that, as there is no supply of oxygen from top and bottom, what will happen? It won't burn. As we said, that air, oxygen, combustion. First case, air is, we are getting air from top and bottom, both, right? In the B option, we are getting from top, which is not enough. Due to that reason, it will be blown out. In the last one, you have seen that what will happen? What is going to happen over there is, yeah, what is going to happen over there is, see, It is completely closed, no air. If no air means what will happen? What will happen basically? No air, no combustion. Now, few of my students will be very smart. They'll ask a question. If we keep a candle where air is too much, okay, air is too much, what will happen to the candle? Can you tell? Okay, let me ask a question. If I give you, suppose you are eating daily 2 chapati, okay, daily 2 chapati you are eating. If I gave you 5 chapati today, okay, if I give you 5 chapati today, will you be able to eat it? No. Okay, nobody will be. Either you have to cry or tell that later I'll eat, or that is your capacity, right? More than 2 you cannot eat. Same thing with candle. They need few amount. It's not like that you are passing some storm of winds and they have to burn. They have to do combustion. No, excess of everything is very dangerous. It can be anything. Okay, so understood. For combustion, our oxygen is very important. Okay, for combustion, our oxygen is very important. Now done this thing, we have understood till here. What did we understand? What is combustion, what is combustile, what is non-combustile? Then we have done activity for combustile and non-combustile. Then we have done activity for how oxygen is very important, right? How oxygen is very important. Now let's move to the next one. I have a situation for you. If suppose there is a fire, okay, if you might have seen in some houses, there it will catch fire, right? If suppose fire, a person caught fire, okay, the other people will suggest, this is very important, right? Like people will have told you in disaster management and all those things, that you have to wrap the person who caught fire with the blanket. Okay, why we are covering that person with a blanket? What is the reason? Generally you have seen, right? Why, what is the reason to cover? Why to wrap up? My question is, why to wrap up? Why to wrap up? Because what is our mantra for combustion? Our mantra for combustion, not mintra, okay, mantra I'm asking. Mantra for combustion is our oxygen. Okay, our mantra for combustion is oxygen. If a person caught fire, if you are wrapping blanket, okay, you are cutting off the supply of oxygen. What you are doing? Cutting off the supply of oxygen, right? Supply of oxygen. Now if you are cutting off the supply of oxygen, how it is going to help? What it is going to do? Basically, if you are cutting off the flame, the combustion, burning will be stopped instantly, right? You might have seen people giving you LPG cylinders, and they will be giving you some cautions, right? That if cylinder catches fire, throw jute bag or throw blanket, or use you will be having that water, right? Water with force. Now you might have seen people, fire extinguisher, people. Have you seen what they do? What do they do? If you have seen, a building has caught fire, okay, they will come, they'll bring their van, and they will be spraying some white coloring thing. What is that? Everybody knows, right? That is a water. That is water. So how water is going to stop that combustion? Now few of you will be telling that you know, right, ma'am, water won't help in burning things. No, if you take water, upper side oil, burn it, it will burn. Then how water is stopping the combustion? Due to excess water. Okay, due to excess water, what is happening? Again, they are cutting off the supply of oxygen. As they are cutting off the supply of oxygen, the combustion or burning of that thing is stopping. Okay, understood? Two things we learned. If we are wrapping a person with a blanket, what we are doing, how the combustion is stopped? By cutting off the supply of oxygen. Same thing with fire extinguisher. If a building or any property catches fire, then how they are going to stop? With giving excess water. That excess water will cut off the supply of oxygen, right? Now, till here all good, all okay? I hope you Understood, right? Now, let's move to the next one. Suppose, okay, suppose, let's take, yeah, suppose you are taking paper, you are taking paper, then you are taking wood, okay, fine. Now, if you take paper, burn it, you will be able to burn it very easily. Burns easily, correct? It burns easily. Now, wood, if you are taking a wood piece, okay, now burn it, you will be able to, like, this much thick wood you will be having, okay. Let's suppose this much thick, yeah, this much is enough. If you are using this much thick stick or wood piece, anything, if you are burning it, will you be able to burn it? Tell me, will you be able to burn it? This is very easy, but this is not so easy, sorry, not easy. Why? Now few of you will be telling that, yeah, we can burn it, you can put some ghee, you can put some camphor, you can put this or that. But remember, burning of paper does not require camphor, ghee or anything, but burning of wood is requiring something or else. Why? What is the reason? We will learn about that. But if I add wood plus kerosene oil, old times, olden times, okay, if you are using kerosene oil, it burns easily. What is the reason for it? What is the reason? See, paper has a different temperature for burning. Wood has a different temperature for burning. Means if you are trying to burn something, they, all of them, like every from starting, you know that people will be telling you, right, that everybody is very, very unique in their own manner. Same thing happens with these things also. Paper has a different property. Wood has a different property. So burns at both of them burns at different temperature. Okay, both of them burns at different temperature. Okay, both of them burns at different temperature. Now, what temperature do both of them require to burn, start burning or start doing combustion? So there is a temperature called as ignition temperature. What? Ignition temperature. Ignition means what? Burning. Okay, ignition means burning basically. Now, ignition temperature, it is defined as the lowest temperature at which a substance burns. At which a substance burns. Okay. So paper has some criteria for ignition different. Like suppose if we take a measure on scale, like suppose 2 to 5. Okay. Paper is burning easily. So let's take that its ignition temperature is 2. If wood is taking time, let's take that it is 5. So all of the different materials have different temperatures to burn. Until and unless they are reaching that temperature, they won't burn properly. Okay, they have to reach that temperature. That is called as the lowest temperature at which a substance start to burn. Right? So in this video, we learned about what is combustion, what is combustible substance, what is non-combustible substance, what is ignition temperature, and how we are going to stop the fire around us, right? By cutting off the supply of oxygen, right? Fine. I have a small question before going to end this video. If we are eating food, okay, if we are eating food, that is a complex substance, right? Complex substance. You have heard that in bio. This complex substance will break down, right? Break down. Is it a part of combustion? Yes, no. Will it give us something? Yes, we can say that it is a kind of combustion. How? Complex substance is breaking with help of what? oxygen, right? Break down into simpler substances. How it is going to break down? With the help of O2. We need oxygen for that, right? We are inhaling oxygen, right? Don't tell me that you all are inhaling something else, right? We are inhaling oxygen. It's not like everybody will be like, no, ma'am, we are inhaling carbon dioxide, we are inhaling ammonia. Yes, you are, little bits, points, parts, but oxygen is very, very important for you to inhale and survive, right? So oxygen is considered as a major part. Now, as you are inhaling the oxygen, that whatever food you are eating, oxygen breaks that food and gives you heat. In the body, it produces heat. That heat is converted into energy form. Right? See, there will be a lot of people who feel low if they don't eat. There are only few people who will be very happy to have one meal at a day and they are very, very, very happy, right? But it is not the case with others. Okay, they want to eat all the time. Why they want to eat? Because they have low energy. As they are eating food, they are getting some energy to do work, right? So half of us, including me, we are eating food to get energy. How we are getting energy? With the help of breakdown of the substances, right? Now, combustion, combustile, non-combustile, and ignition temperature. I hope that it was very, very clear for you, right? So, thank you, all of you. I will see you in the next video. Thank you.